Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling question number 5 from the mid-year exam, which was written in the province of KwaZulu-Natal in the year of 2024. Yes guys, we are still focusing on mathematics paper 2, and please do expect a total number of 8 videos since this question paper had 8 questions in total. And that simply means each and every question will have its own video. And secondly, guys, please do take these seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video, guys, to your peers so that they may have the same edge as you. And also, guys, please do help us grow the channel by just subscribing. Né? Okay, in the diagram, the graph of G is drawn in the interval where x is between a negative 180 degrees to a positive 180 degrees. Nah? And then we are given the coordinates of our local minimum value. And then we are told that those coordinates are negative 90 and negative 2. Okay, firstly, they want us to write the value of A. A is just equal to positive 2, right? But if you wanted to calculate, you would have said since g of x is equal to A multiplied by sine x, you do have a point on your graph whereby y is negative 2 if and only if rather x is negative 90 degrees. So therefore A is basically negative 2 divided by the sine of negative 90 degrees. This will just give you a positive 2. So A is just equal to a positive 2. Okay, now I'm told that on the grid provided in the answer book, draw the graph of f of x for the x values which are just between negative 180 and 180, right? Clearly indicate the intercepts with all the x's as well as the turning point. Okay, and endpoints of the graph. Firstly, guys, they have. They want us to draw a graph. Ne? There are certain steps, guys, that we have to draw the graph. F of x is equal to 2 cos of x minus 30 degrees, right? Yes, it is. Okay, there are certain steps. Step number 1, you must find your period. The period is just 360 degrees divided by the coefficient of x, which is 1. So the period is just 360 degrees, right? So this thing simply means that your graph, the full cycle of your graph will happen in a space of 360 degrees, right? You will have 2 peaks within 360 degrees of your graph. Okay, and then now let's find the interval. Our interval helps us, guys, to determine the important x values of our graph. Né? The interval helps us to find the x value at the turning point and the x value at the and the x-intercept rather. So interval is just period all over 4, which is just 360 over 4. That's 90 degrees. So this thing simply means every after 90 degrees, you'll either have the x value turning point or the x-intercept every after 90 degrees. Nah? And then now let's draw our unit circle. Unit circle, guys, just tells us which is the y-intercept and which one is the turning point. Né? So it's called a unit circle because the distance from the center to the circumference is 1 unit. So that's just 1 and 0, the coordinates. I have 0 and 1, negative 1 and 0, 0 and negative 1. Okay, since my graph, guys, since I have negative 30 next to my angle over there, that means my graph has been shifted 30 units to the right. So my graph will never start at the origin or rather at the y-axis, but my graph will start whenever x is equal to 30 degrees. And then for me to find these other points over here, I just need to keep on adding my interval together. So 30 plus 90, I simply get 120. So 120 plus 90, this will just give me 210 degrees. Are you together? But I don't have to go further because I'm restricted at 180 degrees. So now let me try and accommodate the negative angles. How can I accommodate negative angles? By subtracting 90 from my starting point. So 30 minus 90, this will just give me negative 60. Negative 60 minus 90, that's just negative 150. Negative 150, let me check. Negative 60 minus 90, yeah, that's negative 150. Negative 150 minus 90, it's just negative 240. I don't need to go further because I'm restricted by negative 180 then. Yeah? And then all I have to do, guys, I just need to go and check the values of x. That's 1, that's 2 over there, negative 1, and that's negative 2 over there. Yeah? I just need to go and check the values of x from my coordinates of my unit circle, right? If I was drawing a cos graph, a sine graph, I was going to check the y values. But now since I'm drawing the cos graph, I'm checking the x values over there. Okay, whenever I'm at 30 degrees, what is the value of x? The value of x is 1, right? Please remember that, guys. These values of x will just give me this guy over here. So whatever value of x, I need to multiply it by 2 for me to get the y value. Are you together? So when I'm at 30 degrees, x is equal to 1. So 1 multiplied by 2 is just equal to 2. 30 degrees is somewhere here, né? That's 30 degrees, 60, 90, 120, 150, and 180. Negative 30, negative 60, negative 90, negative 120, and negative 150 over there. Okay, so 30 degrees is somewhere there. Are you together? And I know that x is 1. So 1 multiplied by the 2, I'll simply get 2. So I'll go and indicate y as 2 whenever x is 30 degrees. And then now whenever x is 120 degrees, x is equal to 0. Are you together? So 0 multiplied by 2 will simply give me 0. So I'll just go and indicate there on the x-axis when y is 0. And then at 210 degrees, I have x as negative 1. Negative 1 times 2, it would have given me negative 2. So the graph was going to end there. And then let me accommodate the negative angles. At negative 60, the value of x is 0. So 0 times 2 is just 0. So my graph should pass there. And then negative 150, the value of x is negative 1. And negative 1 times 2 is just negative 2. So I'll have another point over there. And then negative 210, negative 240 rather, the value of x is 0. Then 0 times 2 will be 0. So the graph is going to pass there. Yeah? Okay, so how am I going to draw this graph of mine? This graph of mine was going to be like this. It was going to be like this. Go to the turning point. It was going to be like this, right? But remember that, guys, I am restricted. I'm not supposed to exceed negative 180, and I'm not supposed to exceed positive 180. So my graph will just end over there. Are you together? So this will be my end point, and that's my starting point at negative 180. So that's how my graph would have been. And obviously the stationary points, it would have been negative 150 degrees as well as negative 2. The other one is over here at 30 degrees as well as positive 2. Those are my two stationary points. and obviously my x-intercept, the first one is at negative 60, the other one is at positive 120. That's how, guys, you could have drawn your graph now. Okay, and then now they want us to find the range of f of x. Whenever, guys, you scan your graph vertically, you can only see your graph whenever y is between negative 2 and 2. Your graph you cannot see your graph below negative 2, and you also cannot see your graph above positive 2. So the range over here, y is just between negative 2 and 2. Now they want us to find the period of g of 3x. G of 3x would be something like this. G of 3x would simply be 2 sine 3x, right? So therefore the period will simply be 360 divided by the coefficient of x, which is just 3. So the period will just be 120. So the period of g of 3x will just be 120 degrees. Okay, and then now they want us to determine the values of x if both f and g are equal, and we are supposed to show them algebraically. Let us find our general solution. F of x is equal to g of x. That's 2 cos of x minus 30 degrees is equal to 2 sine x. G of x was just 2 sine x, right? And then I can divide everything by 2 over there. Let me rewrite this like this. So that it will make more sense. Sine x is equal to 2 cos x minus 30. I can divide both sides by 2. This will just give me sine x being equal to cos x minus 30 degrees. Are we together? Okay, I can change sine x to look like cos, né? And if I do that, I'll simply have cos of 90 minus x is equal to the cos of x minus 30. If guys you're solving x and x was at the x was at the exponent, né? If the bases are the same, you could have just dropped the bases and then exponents would have been equal. Same thing applies over here. If trig ratios are the same, you drop them and then the angles are equal. But only express those angles whereby the trig ratio you have at the end is positive. My trig ratio is cos. Cos is positive in the first quadrant and also in the fourth quadrant. So I'll simply express the angles in the first quadrant. I'll simply write 90 minus x is equal to x minus 30 degrees plus k 360. And then in the fourth quadrant, I'll have 90 minus x being equal to, angles in the fourth quadrant are written as 360 minus x minus 30 degrees plus k 360. Are you together? Then I can solve for for x over there. I'll have negative 2x being equal to negative 30 minus 90, that's just negative 120, plus k 360. Are you together? And then I can simply divide every term by negative 2. Then x will simply be equal to 60 degrees plus k 180 degrees. You don't have to make the period negative, guys. Now you can leave it as positive. It doesn't matter. So this is the first general solution we have. And then on the other side, you simply have 90 minus x is equal to 360 minus x plus 30 plus k 360. Are you together? And then over here, we won't have, there's no solution over here. Why? Because whenever I bring x to the other side, I'll have positive x minus x. I'll have 0 on the left hand side altogether. So on the left hand side, I just want to have x. So this one does not give me any solution. This is the only one that gives me solution, right? So I just need to go and find the solutions within the restriction I was given. I was given a restriction over there of negative 180 and positive 180. So I just need to substitute different values of k. Firstly, when k is equal to 0, I know that x is equal to 60 degrees. That's the first solution I have. Secondly, when k is equal to negative 1, I'll simply have 60 minus negative 1, minus 120. This will just give me negative 120 degrees as my other solution. Do I have another one? Nice try. So these are the two solutions I have now, guys. And yes, it makes sense. I can see that at 60 degrees my two graphs intersect. If my drawing skills were good, this graph was supposed to intersect over here when x was 120, but it's fine. So according to the general solution, x is just 60 degrees or x is just negative 120 degrees. That's how, guys, you're supposed to solve that general solution. And then now I'm supposed to determine the values of x whereby okay, the values of x in the interval whereby g prime of x is equal to 0. The derivative, guys, is always equal to 0 at the turning point, right? So they want me to find the values of x of g at the turning point. They are just it's just 90 degrees and negative 90. 90 degrees and negative 90. So g prime of x will be 0 when x is plus or minus 90 degrees. Okay, the values of x whereby the graph of f is above the graph of g. Those two things, guys, they only occur on this point over here, né? So that will simply be whenever x is between negative 120 and positive 60. Between the two x-intercepts, the graph of A of f is above the graph of g. That's how, guys, we're supposed to tackle the fifth question over there. So please do stay tuned and wait for more videos. Thank you.